Hello everyone, welcome in another tutorial of the Kubernetes. Now today we are going to discuss very important topic of Kubernetes. We've been covering a lot of topics lately, which means that we have covered whole series that how to install Kubernetes. Then we have seen that how you can set up a cluster and then how you can do different stuff in it, like orchestration, basic networking pods, like a lot more videos. And now today we are going to see that how storage works. So essentially, if you have been following our channel and watching all previous videos, in the Docker series, we have cover this topic shortly because practically in many industries, not using Docker or any other technology for the storage, security, and networking management. Mostly they are using the Kubernetes because it's providing a more good feature and optimal way to managing the storage and all those stuff at the very vast scale as well. So that's why it is the industry practice. So without wasting any time, there are different type of storage. Purely we're going to discuss all those today. So basically, with respect to the type of storage, we have standard storage and managed storage. Standard storage just simply means that your storage lives on the actual server. And managed storage mean that might be sometime it is possible that your cloud service provider like AWS and using EBS volume, for example, or any other, they're using this storage externally, and this is kind of managed most of the time. When this is the case, then definitely there is a little bit difference how you manage those two. But yeah, in the end, we are going to discuss the main feature of storage. What is the empty directory, and then host path, ConfigMap, secret. But down the line, we are going to discuss that how you're going to really create the PV and PVC. This is a very important concept. If you graphically and with diagram, you are able to um, if you are able to actually grasp this concept, then it is very easy for you to overall understand the concept because the main trick is hidden how the architecture really works under underground under the hood. When you understood and when you understand this, then it's very easy to grasp the concept as a whole. So, well, great. Let's discuss them one by one and let's practice them one by one too. So the first and very simple stuff comes in the empty directory. As the name suggests that sometime this is the mostly used when you are using the multi-container pod. Normally it is the in the industry you normally don't use multi-container in single pod, but only when it is required. And when it is required, we have discussed in the previous video too. This is required, for example, when you have two container, for example, and these two containers are depend on each other. One container has the ancillary file mechanism fetching some code from somewhere, and it's getting some code from the another service, and the second port purely runs the application. Why you make them segregate? It is sometimes very important to make the processes segregate because the configurations are on the one container and all other stuff running on the one container. When you pretty much need to develop or change the or deploy new configuration, definitely you can easily configure or tune your one container. And if you copy multiple RCs like replicas, and you don't have to worry about changing the configuration. So yeah, that is the use case. Let's draw something to help us understanding. So my approach would be that first I will convey whole concept, and then we'll practice this practically one by one. So this is, I think, so good approach. So very simple. So here, for example, this is my pod here. It's a big pod. So I don't know, whenever I just draw it, it's always like fill automatically, but I really don't want to. Here's my simple container pod. In this pod, I have something like this is my pod here. In this pod, I have two container. One is the primary container we have discussed in the previous video, primary container. We also have discussed that what is the use case of these two. There are different use case for these two always. and this is the secondary container. So normally what happens is that you have two container, you're running them. You need some drive, some share space where you can really change the stuff, which is persistent kind of thingy. For example, I can give you an example. So this is my container where what I do, I get the code from the repository. I set the environmental variable. I see the database connections like my database host and everything, and all other variable which is very necessary to run this container. And then I do this, and whenever my secondary container is ready, only and when all the configuration maps, everything, every environmental variable is ready from the GitHub, I pull the repository and make everything ready. When everything is ready, then I definitely run this container, and this is a good approach. Why we need storage? We definitely need storage because we need a shared drive where we can save everything, even in the case of the failure when the pod is gone your container are still there. So let us search something drive here. Okay, for example, very similar to that, I need some shared drive here, and I am just drawing here shared drive. And shared drive is kind of a thing that is somehow, you know, connected with that. Might be it is possible to do this like that. And I need another. Okay, so for example. I need something like that. Okay, what is happening here? It's very simple. This is the empty host. How I call it? I call it empty host. EMPTY, empty host. No, sorry, empty directory. Empty dir. What does that mean? It is very simple that I create an empty directory which is automatically created. This is the shared drive created by the both container. And whenever I need to share something between these two containers, definitely there should be some path between these two. And what I do, I just upload everything here in this drive, and it's automatically accessible by a secondary container and secondary container and primary container. I need some file to store here, and the communication and all the primary communication of the file and data is very easy between these two containers. But there is one problem with that's well, great. That serves the purpose that creates some volumes, great. But the problem is that this is, as you can see here, is that it is actually in within the pod. The problem here is that it is within the pod, which means that in case that that pod is get destroyed, definitely your volume get destroyed, and that is what we don't want because in the realistic setting, the mostly need of the volume is to make to persist the data. Why we persist the data? It is highly required to persist data because definitely there could be any damage or there could be any problem with the port and port get destroyed, but you still have your configuration and all the important logs and everything saved. And as and when required, you can just connect again with the container and you're good to go. Great. So how you duplicate this actually? I guess right like that. Now the second stuff is this is simply pod again, but this time we have not this empty directory, but we have the second option, which is host path. As very much clear from the name itself, um, it is very similar to Docker volume. When you want to spare some directory or declare some directory as a path in your physical drive, and this physical drive is somehow connected to your physical drive is somehow connected or physical drive somehow located on your SSD or the hard drive. And then this is also a good way to change dynamically your container. Uh, why it's also important? Let me just show you here. For the sake of simplicity, I can just do this. Okay. For example, here this time, as you can observe very easily, This time my volume, my host path is outside of port network. Host path. It is very much clear from the name itself that it is host path, and host path lives actually outside of our pod. And if any case of pod get destroyed, all the data persist here. And secondly, for example, I need to change some configuration here. I need to change something here. I don't have to log in or exec into the pod and I execute something or I recreate whole services again of this Kubernetes cluster. I don't have to. I just go here. This file path is automatically, for example, I can also show it here. So how it look like, for example, this is slash tmp slash mypod or nginx, whatever. This is the path, for example, and this path is directly mapped to this container. And this time it is into the var and lib, for example. Here you can see this time this is in the var lib mypod, and you configure your app that all the environment variable configuration file, whatever it is, you can get from this path. And now, for example, you want to change your database connection. You have database connection to HTTP something something, and you need to change in your hard drive, and it automatically get implemented in your pod. So that's actually the way to do it. And that's actually easy way to do it. This is the host path, very easy peasy, nothing that difficult. Then comes um, another style. Then comes another config map. So yes, so the purpose of the host path that it really exists, this is volume on your storage. And the config map again is for configuring your again, for example, you have some configuration stuff similar to host path. Let me just the main difference between these two is really they serve really different purpose because host path is very similar to Docker hosting your local file as I have shown here. As I have, you can see shown here that this is actually hosting a real path to your pods. It is tightly coupled, it is coupled or it is connected to the pod and not a very flexible option, but still it serves the same purpose. But if we see here, the config map serving complete different purpose. Config map, as you suggested again from this name. So most of the time the name is very self-explanatory because config map is configuration map. And what do we mean by the configuration map? That it serves the purpose of configuration. For example, there are two major difference. This is not a directory storage. You have to understand this. This is not a directory storage mapping, but this is a simple Kubernetes service. What do I mean by Kubernetes service? As you can see here, this is proper API version. The kind is similar to port. The kind is config map. The metadata, whatever name you can call your config map. And here actually you're starting your writing your data. For example, here you can say that database name, my database. Database URL HTTP localhost port number 6346. Then I can say that password secret.password, for example, or something like that. Now I create one file. This system is nothing. It is the just common service of your this is common service of your Kubernetes. It can be listed by the kubectl get describe, and all the possible operation can be done on it. And it is a simple file. What is the beautiful thing or thing about this file? When I'm creating my pods, my RCs like replica control or replica set or whatever I need. whenever I deploy my service, I change, rollout, whatever I do the Kubernetes, I can reference this path. And here you can see that it is referring here. For example, I have mentioned that my database URL and my database port and whatever variable, you can name it inf, and under the inf, you can say that get the value from, and then you can say please refer to my config file, config map ref, and then you can use the name of your config file, and then you can use key and the value underneath. So this is the simple, pyramid of that. And regardless, here we have 1000 different configuration of any application. We can always refer them in your over all the sources, regardless if it is port, it is RC, it is deployment like DEPLY, or it is whatever. It could be the any service of your Kubernetes, and you can simply actually refer your configuration map. So this is quite different purpose. Definitely, it is file which saves your all configurations. And the second thing is that these configurations are really, really dynamic. What do I mean from dynamic? Dynamic means that these services are really changeable. If I change them on my host file and I just refresh, the pod automatically get those files. So this is the second benefit of that. Then let's come to the secret. Secret is just a same copy, a ditto copy, a carbon copy of this configuration map, but it has an additional layer which decrypt your secret data. It is for the password, for as I have mentioned here, that maybe you need the username and password of your data, and this password and data is your sensitive information, and simply you can just obscure or oblique this information, and this information wouldn't be visible anyhow anywhere, and that's how you can save your secret, which is completely encrypted within your Kubernetes cluster, and it won't be uh, visible in a normal text way. So this is the big benefit, and definitely is being used by the industry as a whole. So well, great. This is the concept number one, which the concept is that, well, definitely we can use configuration map and all these set of services to achieve something which is complete storage stuff. But there is a couple of problem, or I can say that there are some big problem with this existing setup. Could you just tell me what these problems are really? What these problems are? So there are definitely some problems. Now the problem is that number one, you have to manually what you have to do. For example, you have 10 replica in three different environment. You have environment test, dev, prod. You have 10 replica of each application, and you have now, for example, 30 different stuff is running there with three replica. If you have 10 replica, then definitely there are much more. And for example, your 30 different server are running, ports are running, and you need to configure this port manually, number one. By manual, we mean that you need to specify path again. If you don't specify path, definitely it's going to fail. Your ports are not going to work. This is the problem number one, that it is kind of configuration hefty. Yeah, sure, we can use Ansible or any configuration management tool, that's for sure. But normally, what is the thing that if something is natively available, why you won't do a extra tooling? It is extra overhead. Definitely, that needs a extra setup, extra expertise, and might be your organization is not comfortable with that. There are like hundred of different technology and alternate to do similar stuff, but your technology always want to achieve with minimal effort to that. So that's why it is not a native solution. Number one, it is not a native solution, which means that it is always a best idea to use a native solutions. And this is the problem number two. And now, secondly, there should be a beautiful, highly managed and kind of effective system to achieve that. Well, this is possible, and this is possible with the concept of PVC and PV. What does that mean? PVC and PV. PVC and PV is nothing but your, for example, hardware system. You have big server here. Let me just show you one thing here. For example, I have this big, I have something like this. This is my server. I name it as a server here. Server. This is my server here. And in this server, I have hard drive running, right? I have hard drive running here. It's maybe for example, 30 terabytes, or I don't know, a big drive attached to it. And what I want to do, I want to actually create some system that gives me some control over it. Definitely in this case here in the host path, you can just say you can give the path of that file. But naturally, as you know, we have discussed this many times that containers are kind of always designed so, and even the Kubernetes cluster to get as much as storage is available, as much as processor is available. And this is the same for hard drive. As much as drive available, your Docker could or your containerization application could get suck up all those power. And this is not very optimal. Sometimes you need to create a hard limit for that so that that hard quota is over. You get some warning, stuff like that, so that you must get some of the storage available for other stuff too. So this is number one kind of granular level controller tuning you need to achieve. And secondly, there should be some managed service. And for this reason, we have the beautiful concept of PV and PVC. PV is actually persistent volume, and and then we have persistent volume claim. Claim is claim that your okay, very easy stuff here. What is this? There are two stuff is going on here. This is a managed service, completely managed by kubectl intrinsically, and there are two major building block of this. Number first is really number first is really persistent volume. What does persistent volume do? It's just go there and try to create a small partitions. And just go here, come back here, and give you some volume back. It give you small volume, for example, small volume of one or 10 terabyte each, right? It give you small volumes, and these volumes are nothing but they are a kind of volume, and let's see again the third volume, right? Well, you have something very similar to that, for example, and here is the stuff. It's give you kind of 10 TB each, 10 TB each, right? It gives you that much for everything. And this is now your PV. PV assign you something, give you small partition, and it is good thing that you have that partition. And now you have set some hard limit, right? For example, your application, whatever application you're writing, you write some replica service or some deployment. and you know that your application number one needs or your one service need that much of your that much of space. Let's say like that your service need less than that. Less than that, I mean that your service need maybe not 1 terabyte or 10 terabyte. It may need 6 terabyte. Well, now what your service is trying to do, your persistent volume claim locks your request that, well, your application needs 6 terabyte, but in my partition, I have 10 terabyte each. I don't have exact number of 6 terabyte, but of what I should do, I am not allowed to give less than 6 TB, but I should look for at least 6 TB or more than 6 terabyte, which is okay. If I give like 6 terabyte needed, I give 10, it is a win-win situation. It is a good situation that you're giving more than that, right? And this is beautiful. So yeah, for example, there's that, and your persistent volume claim and your the job of this persistent volume is to partition your system. And the job of your persistent volume claim is to give you the claim, lock your required minimum capacity, and until and unless you don't delete it, this is available. And if this is filled, regardless if your application is running or stopped, your next application won't be getting this much, or the system would try to allocate you the second one. And you can really, whenever you don't need it, you can delete it. But that's the thing that your complete storage is exactly managed by the cluster automatically, and everything is managed. And this is the beautiful solution. So now let us, after this concept now is clear that we have these much building blocks of the whole storage. Mostly, they have different purpose. So this is empty directory, host path, config map, and secret. And persistent volume and the persistent volume claim is something a storage service. And in total, you can call this stuff as a whole as you can call this whole thing as a storage class. And you can define multiple storage classes. Storage class, and you can define multiple storage classes definitely, but that's the overall stuff down here. Let us now grab our VirtualBox and try to implement this one by one. Let us first see that how you do it. Okay, for example, to practically implement this, let's first try to understand it that we have this port, the metadata is volume port because we want to test this. In the specs, we want to create a container which is CentOS. Well, it is persistent image pull policy. It's a simple policy that if it's processed or not. Uh, name is name, and so any command we are running because without running command, your container get automatically killed. You know that from the lesson of Docker already. And there is a specific word, and this word is volume mount. This is the imperative or keyword or declarative of the language of Kubernetes. Whatever you do with volumes, you do it with the volume mounts. This is the camel case. And mount path is your path at your host system, which is demo one. Now this is your path of your application. Demo volume, right? This is the name, this is the path at your application. Your second image is this one, and you got this demo volume with the path of demo 2, and the same volume is attached to demo 3 with the third container. In total, one port, three container in it, and in the volume mount section, you always come to the volume, you name something to it, right? And then you create empty directory. And with the empty directory, it means that it's going to get some directory automatically map onto your pod, and it is automatically accessible from all the containers. That's the thing. Now let me just go to VirtualBox. I haven't VirtualBox. Maybe I can run some stuff here. Okay, master, node 1, node 2. Our server is now ready and we have some services already running which we can delete. Okay, what we can delete? We can delete our whole deployment, right? How we can do this actually? kubectl delete deploy deploy and pref. Okay, the pref is deleted. kubectl get all. Oh my god, my spells. And it's terminating, which is good thing. Okay, and now we are going to check something, or we are going to add something as usual, which is nothing but, or we need to change something. No, we don't have to change anything. We are just creating a pod with 3 containers, and there are different volumes available within that. Let's say like that, we can directly give the file path of raw, go to raw, copy this, come back here, come back into the master node and kubectl file path, Control Shift V. Okay, what was the command again? Apply, and now there should be kubectl pods, get pods, get pods. As you can see there are 3 sources are being created. And now there's, if you inspect these ports, there would be common share folder between them. Okay, and the if we inspect, for example, kubectl kubectl describe port and name of port is my volume. This is not automatically popping up here, which is sad. Okay. Here you have a lot of different information. The different container has been created, right? The class of node, and in the configuration map, we have right now nothing custom defined. And here is the mount path, right? One is from the by default from the Kubernetes itself, and second is demo 3 from demo volume, right? This is container 1, demo 2 for the container 2, and there should be one more above. Here is the, and name of the volume is demo. I can get the container name to check my volume here. I copy it. I come down here. I have 3 container. As you can see here, these 2 container, one created 2 in the name of the container. What I can do, I can cube ctl interactive mode. And then what I can do, I can say that name of your pod. What was the name of pod again? Da, 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 da. Name of the pod I can also get from here. Manifest file. My volume pod. Cool. This is the name here. I paste it here. And now I here normally in the Docker fashion I can say bash, but because this is multi-container, there are like 3 container running in it. Container 1, container 2 with Ubuntu and blah blah blah. I should write the container name with C. And now here I use the name of my container like that. And then now instead of that I can use bash directly or what it is. Okay, maybe there is no that. Oh, there's nothing that. Okay, there is no double slash at all. And it is saying that it is depreciated and my volume don't have that. Why? kubectl get ports. What is it? My volume port. My volumes port. There is my volume port, right? Okay, the container name is not right here because while copy pasting, we have missed my volume container here. It's really sad. Now I've said DFH. As you can see, demo one is completely attached here. And a similar fashion, I can do Control PQ to exit it. Then I can go to second container. I can again repeat the same information. Now the volume demo 2 is attached, and then I can exit this uh, port here. And similarly, I can test my volume 3 here. It is due to some reason terminated. Okay, but you understood the concept. kubectl get pods might be dash output is void. Why would this not working? Maybe the container name is something else here. My volume container 3. My volume container. My volumes container. Oh, my volumes container 3. kubectl exec. Might be it's suggesting that you use that here. I don't know. Instead of using it here. I don't know. Yeah, but it was working fine for container 2, right? Yeah, might be the executable what we are trying to run in the third container, which is exactly here. Alpine image container 3. This sh is somehow not working, but it's fine. We have 2 container. Uh, exact attach failed. Read escape sequence. I don't know. Okay, whatever it is, I don't know, but there might be something. Okay, executable. Not find. Sorry. Okay, now we understood this concept, and what else we can cover here? Okay, the problem we are getting here is that the third container is Alpine. Okay, sadly, Alpine don't have any shell thingy, which means that we need to do. Container 3, we need to go with shell. Great, DFH. Ooh, lot of stuff here. Mine has little bit different stuff. This is overlay network. There should be demo, but we are not able to see any demo. We have any demo overhaul or not? Okie dokie. What we can do is that we can come with SH and now DFH, and we are in demo 3. Now let's create CD into demo 3 and touch. I am demo3.txt. ls now just pq pq, and now let us just go to maybe 2 bash. I am right now in container 2 and dfh, and now we can go to demo 2, and your I am demo 3 file is already accessible here. Here I can see I am demo 2, and this file, which is I am demo 2, should be already accessible by demo 1. Both of files should be in fact accessible by demo 1. And if I go there, dfh and cd demo 1, and as you can see that both demo 1 and demo 2 files are accessible. And yeah, that's how you can access your demo file very easily and very fine. Great. So that was the concept of empty directly. Now let's go one step further. And in this step, we are going to discuss that how you can really set up the host directory. Okay, then let's come to our second main type of the pod, which is the host path. Let us just go here, go one step back, and in the volume, find host path. Host path volume is here. It's nothing a fancy stuff. Everything as we discussed before. We are creating a pod with the container name test container. This is volume mount as I described that. This is the keyboard always used for volume. Name whatever name we can, random name we can assign to it. It is our name of what we can choose. Here is the mount path within the application, and this is then volumes. Under the volume, we introduce something extra here, which is namespace. Our name is host volume. And in the host volume, this is the declarative or the language declarative. And here is the path on my host or on my server, physical location, and type is directory. And now this is the optional field. Now let's go to raw. Quickly copy this, go to our master node, and here I can say first just kubectl delete port and okay, my volume port might be that deletes it. Still inside port. And oh, it's kind of stuck now. I don't know why that would happen, but it's sad. What happens if I do that? kubectl ports. Okay, kubectl get all. Cool. Now kubectl file f, and maybe I have some copy log here. Yes, I do have some. Paste and then apply is the universal command. I have created pod kubectl get pods. Okay, I have this pod with the host path. Container is creating. Container is creating. So I have one question for you guys. So does the will that container be created or not? Or put the question other way around, that why the container is not created. Normally that doesn't take that long. It is just a matter of second. It should be created. It should have been created in 7 seconds, but it's still there. And what do you think why it is so? The problem really here is that if you guess it right, that here actually we have given the name of the directory, but this directory we never created, which means that this is the required step. And we have to do that until and unless we don't do this on the master, it's never going to create itself, right? Temps log, temps log, temps log. We are going to copy this here. We are going to go there, make the R. Oh my God, this keyboard, this path, and then just go to CD here, CD here, and what's going on here? And logs, as you can see. And now if I again do kubectl get ports, that was the name, right? And what I have to do here, if it is not working anymore, path temp logs, path temp logs. So it was temps or it was temp and then logs. There is directory, but it's not getting picked up or what? still container creating, and maybe I have to now reapply this. And now if I say cube ctl get pods, hey, warum? Äh, Cube ctl inspect host path wall port one. It's not inspected, it's described. Host path temp logs is not a directory. The problem is, you see, that is now a big problem that I'm creating this directory on VM, which is my master node, but my port is getting scheduled somewhere because I need to just also figure this out. kubectl get ports output void, and you can see that this is on Nitro. Then we have to go to the Nitro somehow, which is this one. Need not this one, which is Nitro. Which one was Nitro? This one? Yes. This one is Nitro. We have to now make directory sudo make dir with path tmp logs and this one. Now we can go to tmp and logs. Yes, now in the Nitro, which is this one. And now if I here again say container is creating still, do we have correct or not? Still creating, or maybe I have to reconfigure it again. Mm-hmm. I should inspect it again or describe it. Oops. kubectl describe code. And what was name again? HostPath volume. I guess that when I have re get nodes are ready or not? Not ready. Oh my god. Why it is so? But Nitro was ready, right? Anyhow, and it's get created on Nitro. We come to Nitro, which is this one, DMPLOGS logs. DMPLOGS logs is need to be a directory, right? It is directory right here. And still it's kind of not working. Okay, wait. Okay, it took a little bit time to figure out, but yes, now it's working. Maybe I can do swap of A and also swap of A here too. Sudo swap of A. Okay, swap wasn't, this is kind of very important stuff until and unless you don't do it. Cube, CTL, get nodes. And now you can see it's ready because this swap memory is kind of should be off for the Kubernetes cluster. This is a very important point. And now you can see that your host path is in running state. What was the problem? Now, as you already have seen the problem, because this beautiful example that you have really seen the problems, that what are really the problems for which we need any better solution. What was the problem? I need to figure out that on the all nodes there is path available and the path should be same for every node of the cluster. Otherwise, you never know on the which node it's going to schedule your node or your pods, and that's why it's a kind of hectic work when you have three different environment, four different environment, two different application running. In total, there are 60 server or 60 different pods, and you need to always map up this. This is number one. Second problem is that when you just give it the volume log here, as you see that if this is my PWD, this is my path vol temp log. For example, of my Nitro, my node, one of node, and it is the greedy mechanism. And the greedy mechanism I means that whatever storage GB is available or terabyte is available storage on your volume, when it is needed, it will suck it up whole. It is try to grab everything, which is kind of also not very beautiful solution. For these two reasons, I need a better solution, and this better solution is nothing but a PV and PVC. Okay, let's quickly go here and go to storage, volumes, and where it is might be where it is actually our host class or what? PVs and host path, and here is the PV and PVC, right? Great, this is the PV. PV is nothing but creating a partition on your hard drive. And PV name standard means that you are not using cloud. It is standard, and by default, it is standard too. There are three policies with you which you need to really grasp. Recycle means that until and unless I don't delete any PV, uh, it's actually going on. The data is retained. You can use as many as time. You can delete your ports, reattach PVs, whatever you want to do. It is just like a partition, persistent volume partition. It's theirs until you delete it. Sorry, that means retain, and the recycle means that when your claim is because every PV has attached claim, and when you have recycled it and when you are done with it, definitely, and when you are going to delete your ports or whatever purpose you're using for it, because you have created a partition for some purpose, and this partition is somehow attached with any claim, and when claim is provided, and then the purpose of this is to attach with something, and with which it is attached is automatically recycled. But let me just give you a caution, caveat. Caveat is that this recycle from version 1.4, 1.14, or 1.4 onward of this Kubernetes, this is depreciated. This is not used anymore because nowadays many people are using not standard SDD or hard drive server base, but they are using cloud mostly. And in the cloud, these PVC volumes are mostly managed externally, and you have some rule and regulation to manage them, how to recycle them, you want to keep them or not. This is the decision of company. That's why they mostly just recycle is not there. Retain is mostly used because you need to manage your PVCs by your own. And delete is just obvious that when your application or your attached services are deleted, it's automatically get deleted. It is similar that you create one hard drive. When I delete my application, which is attached to the hard drive, it automatically wipe out the data. And if I say retain, regardless if I uninstall from here, I go there and uninstall any of my software, and my data will retain. If I go here and uninstall, if I choose recycle, in definitely it's deleted, but now it's not used anymore. And yeah, so let's create a PV. You need to, the volume can be mounted as read write by a single node. RWO means that your access mode, your volume is attached to one single mode. The volume can be mounted read only by many nodes. Volume can be read write on many nodes. RWX. You can attach from one and you can read, you can attach this hard drive to another application or other node. So this access mode is read write access mode for your mount, but to single node, to many nodes, and to read write to many nodes, right? These are two for many nodes, and this is for single nodes. So definitely there are different types here. Let us go to raw and create PV. Very straightforward. I go here, I get my PV here, I go into the master. This is my master, great, and here I do kubectl and then get all. Okay, one of the services running. I don't care about that. This is the default one. And let us kubectl apply fv. Okay, kubectl. That's really sad. Kubectl kubectl get PV. This is one PV recycle mean that reclaim policy, that when the claim is deleted, this will get deleted as well. So because this is very important. There are the recycle this is depreciated anyway, but you need to understand this, that how delete works too. When I write here delete actually, read write for a single node, for example. This is for a single node. And available means that right now this status is available because your partition you have created on your hard drive is available to use, and storage class is standard. But here you can see here that this is the recycle. But if I would write delete here, what happened is that my reclaim policy is delete. When I delete my claim, it's automatically delete my PV as well, whatever PV is bounded, and it releases immediately. because PV is nothing but PV is actually the hard drive which is used. And on the hard drive, there is one extra layer which is the claim. When this claim is deleted, it is deleted from here too, from the PV too. And PV is nothing but partition. When I delete my claim, it wipe out my data and make my claim always make my PV again available for other application. Let me tell you what I mean. Now it's available. When I create a claim, this available becomes not available. And minimum 1000 capacity I got for that. And let's see how it gives us something. I come here quickly and um, this is my PV and let's create a claim. For example, this is my application. My application need 500 megabits and I have partition of 1000, which is sufficient. I come here quickly, I go to my master node and I just change this file path. And this is the file again. And now if I kubectl get PVC, and now here you can see that I am the volume is PV my PVC. This volume name is same as this volume name I have created. This should be same, otherwise that won't work. This should be same caveat. This name is must be same and available as a service and already created. Otherwise, your service won't work. Now you have 1000 volume available capacity here because the only available is we are asked for 500 megabits, but it's going to create and give me this much because this is much available and it's greater than my minimum requirement, which is fine. And this is standard, and this is now status is bound. And now if I go here and see my this one was available before my PVC. Now my PVC is bound because it has been attached to my application. And the policy mean recycle. This is working together now, right? Recycle means that it's attaching me a partition. It's giving me a partition. When I delete this PV, it's going to release it again. Yeah, that's pretty much it. And what else? That's how PV work, PVC work, and now you can attach this PVC to your any application. This is the next thing.
.yaml tree or your have a path I have defined my worker node to node. Here, let's create the pod.
Now the last step is that we come here, we come back, and we use this partition in our application. And let's say like this is the port where I'm want to use. This is metadata, everything. Here in the container specification, keep in mind in the container specification where I define my container and everything. Here, the same keyword I have stressed out many times. This is the declarative or this is the programming language name which it uses volume mount, and in the name of volume mount is PV, right? This name you can assign anything, but when you declare that volume, and in this volume, you make sure that name you have defined here, you write it again here, and you clarify that which name I meant here. This could be anything because we have discussed many things before. This could be empty directory. This could be a host path. Here would you would name this and you would say here the host path. You need to tell that which services you are meant by this volume. And here you are telling the service that here I meant with PV, my PV, my storage PV. With the mount volume, I meant name it PV, and this is the path where in my application, in my container within my pod. And here is the persistent volume claim. And the name of my persistent volume claim is PVC. And then it knows automatically that this PVC is bounded to this PV. And then this is a complete chain of path. And let me just create a new port by raw here, and if I go here and I come here, I go to the master here and I say create port, and what else? Cool. And I have created my port cube ctl get ports, and here you can say my port has been created or is being creating. One port is already here, right? I could have deleted this port, but it's okay. Copy UCTL delete port single port. Oh, oh. Get ports and some error we are getting here, and some error we are getting here in this port. Which error we are getting here? Cube CTL describe. I have deleted something else actually. Mm. Ugh, okay, I am deleting this now. Maybe it's great because it's saying that you don't have enough space available on your node. You said, okay, maybe I need to create it again, but you understand it now. I'm now running short of the space. That happen very often, but okay. Mention not. Might be if I create this port here again and okay. This FNML suppose I cannot do much, but yeah, that's how you create the PV. And now if you want to delete this claim, you can just delete your PVC, and then it will be released. And yeah, that's pretty much it. Thank you very much for watching. Bye.